everyone. Hello. How are we all doing? Okay. So just starting off the stream now.
Let's do a char. Let's not do a new line. Let's do a new line here. Char. Let's not do a new line. Let's do a new line.
Let's mute you. Nice. Okay, so whenever the stream starts on YouTube, I kind of get started. Oh, there it is. Nice. And let's do this. Pop out chat. Just kind of what I want. Yep. This, and then also on Twitch. Okay. I know you can't see much right now, but I'm just kind of setting up right now. Okay, got both chats going. I think, not you. Yeah, here we are. Both chats are going, both streams are going. We're all going, boys. All right. So yes, I'm gonna be learning Rustlings. I'm gonna be doing some more Rust today. I think I might also take a look at another project, Converge, that I'm working on, and I really want to get done before the end of this month because I'm going on a trip where I hope to use it. So let's just get started. Let's do some Rust. So just double check. Yeah, okay, that's the right scene. So learning Rust. No, what did I call it? Rust. Yeah, I called it learning Rust. Yeah. Oh, not you. Learning Rust. This one. Okay, and I have Rustlings in there. There we are. Rustlings watch. LCD Rustlings. Okay, where are we? What is our progress? I think it's getting there. Process is pretty good so far. Lifetime parameter. Yes, that was it. So alongside this, I also want to take a couple notes. Actually, let's exit there. Let's S on notes backup. Projects. What do I have here? I swear I had learning Rust somewhere. Okay, learning Rust. CD learning Rust. There's a lot of stuff here, but maybe lifetimes.markdown. Lifetimes markdown. So the thing is that there's a couple of markdown syntax things going on here on the right side, and I'm not actually too familiar with it. Also, really cool thing that I wanted to share is the new browser I'm using. I'm not sponsored, although that would be sick. Vivaldi. It's just incredible. I love this browser so much. I really can't recommend it enough. It's so cool. And just so versatile. The amount of stuff you can do with the tabs is just great. Yeah, little shout out there. Learn Rust book. So here we are, Rust programming language. Let's pin you. Let's also pin this. Where is it? So we got tiles, we got this. Wait, where did I accidentally closed the Twitch, didn't I? There we go. So I want to open that. There we are. But yeah, let's pin this guy. There we are. All right, we're learning Rust. Lifetimes generic traits and lifetimes. So we've done a little bit of trait stuff. So if you remember, traits were almost like interfaces, right? Interfaces that you implement onto structs, and you can implement traits. It's kind of like a reverse responsibility principle here. It's, usually you have interfaces and your classes implement interfaces, or your objects implement interfaces, your structs implement interfaces. However, in Rust, it's kind of the other way around. It's your traits implement for structs, kind of. So it's like, you see here, instead of going tweet implement summary, you do implement summary for tweet, and you go ahead and implement those methods, which is really cool because that means that you can take an external struct, such as from a library, and you can implement a new functionality and implement a new trait, so that now that struct that you need from external library can be used in your code under specific traits without the need for much more wrapping than that, which is a really, really cool concept. However, that's not what we're looking at, because we looked at that last time. We're looking at validating references with lifetimes. Okay. So lifetimes are, lifetimes another kind of generic that we've already been used to. Rather than ensuring that a type of behavior we want, lifetimes ensure that references are valid for as long as we need them. In the chapter 4 with the borrowing stuff, we noticed that a reference has a lifetime, which is the scope for which that reference is valid. Most of the time, lifetimes are implicit and inferred. Just like most of the time, types are inferred, blah, blah, blah. Okay. Let's see. So what would we have here? We define R. We then do a scope block where we say X is 5 and R is the reference to X. R is now invalid, right? Because R is the owner of X. Yeah, and this just doesn't live long enough. Yeah, the value's gone out of scope because R is now the reference of X and X has gone out of scope. So the variable X doesn't live long enough. The reason that X is out of scope, but R is still validly out of scope because the scope is larger, we say that it lives longer. If Rust allowed this code to work, R would reference memory that was deallocated when X went out of scope, and anything we tried to do with R wouldn't work correctly. Yes. Here we've annotated the lifetime of R with -A. Okay. And lifetime of X with -B. As you can see, the inner B block is much smaller than the outer A. Wait, what? As you can see, the inner B block is much smaller than the outer A lifetime block. The inner B is much smaller, is it? That seems a bit weird. Then the outer, yeah. At compile time, Rust compares the size of the two lifetimes and sees that R has lifetime of -A, but that it refers to memory with a lifetime of -B. The program is rejected because -B is shorter than -A. Yeah. Okay. Oh, this one. I was so confused. Yeah, that diagram. Yeah, I got you. So we can fix it with this. We make the lifetime of B kind of reverse. We make it bigger, and this just works. Generic lifetime in functions. So we'll write a function that returns the longer of two string slices. The function will take two string slices and return a string slice after we've implemented the longest function. Okay, so we have string 1 and string 2. We do longest string dot as string, and then string 2. Yep. Okay. Wait, what is this? Note that we want a function to take string slices which are references rather than strings. Because we don't want the longest function take ownership of its parameters. Yeah, that makes sense actually. Yes. So yeah, reference borrows the value. However, what do we get here? What is the compile time error? Expected name lifetime parameter. Okay. The help text reveals that the return type needs a generic lifetime parameter on it because Rust can't tell whether the reference being returned to X or Y Actually, we don't know either, because the if block in the body of this function returns a reference to x and the else returns... Okay, so it's like you need both... Right, I see. They both need to live that long. Okay, so we have a reference with explicit lifetime, a mutable reference with an explicit lifetime. So we fix it with this. That's pretty funky, isn't it? That is pretty funky. Okay, I'm gonna get to doing some of this stuff. We want lifetime 1. This Rust compiler needs to know how to check whether... Oh, what is this? Okay. The Rust compiler needs to... Oh, actually, hold on. Room is too bright right now. Turn this line down a bit. There we go. That's nicer now. The Rust compiler needs to know how to check whether supplied references are valid, yes, so that it can let the programmer know if a reference is at risk of going out of scope before it is used. Remember, references are borrowers and do not own their data. What if their owner goes out of scope? Okay. It's almost like a relief, to be honest. I haven't programmed since Friday, which was work. But I haven't done like fun learning code for a little while now. So I feel like I don't know what I've been doing. I've been reading a lot, which is really good, really fun. But like, you know, that there's like an itch that hasn't been scratched. So really enjoying that. No messages, no one. Let's actually kind of want to check this out. I'm gonna tile both of these as well. It's muted. Let's get rid of the chats. Who do we have? 1 and 1, which I really suspect is myself. Yeah. And then anything else here? No, no one. I am alone. Anyways, YouTube VOD, maybe you're watching. Right. Oh yeah, this is the one that we just saw from the book. So we need to annotate this with a... So the problem here is that we return references to X. And we return references to X so that now result takes ownership, or is a borrowed value from one of these. So it needs to have a lifetime parameter. I think, if I remember right, then we can do a -a. Is -a this? I can't remember the exact syntax, to be honest. Oh, the Rust compiler tells me, which is amazing. So a reference with lifetime of A that returns a reference with lifetime of A. Okay, that will take a little bit longer to get used to, I think. I'm actually going to keep that open. It's a nice little buffer on the left. So if the compiler is just validating the references passed to the annotated parameters and return type, what do we need to change? Okay, so again, we have our longest function. And, oh, this is from the book. This is obviously from the book, yeah. We take a string and we let result. It's so great. The type inference comes from, like, it's like time travel. It's so cool. Need more water. So we create another string. We do string on a string. Then we're going to go with let result. I think we need the lifetime of string 1, which is passed in this parameter. I almost want to say something like this. Oh wait, almost want to say something like this. The function, so y doesn't live long enough. Oh, it's kind of strange. May not live long enough. I think that's probably fine. Let's see. So we had this example here and I decided to skip it. So we have this. And yes, it doesn't live long enough. Yep, thing in terms of lifetime. So the way in which you need to specify lifetime parameters depends on what your function is doing. For example, if we change the implementation of the longest function to always return the first parameter rather than the longest string slice, we wouldn't need to specify lifetime on y parameter. Wait, let's read that again. That just went over my head completely. If we change the implementation of the longest function to always return the first parameter rather than the longest string slice, we wouldn't need to specify lifetime on the y parameter. Yeah, that makes sense. We've specified a lifetime parameter -a for the parameter x and the return type, but not for the parameter y, because the lifetime of y does not have any relationship with the lifetime of x or the return value. Yes, that's true. When returning a reference from a function, the lifetime parameter for the return type needs to match lifetime parameter for one of the parameters. Okay. If the yes, so for example here, like this none of the parameters work here. Really long string, a string return a value referencing data owned by the current function. Yeah, but it's there's a lifetime and there's a thing there. Okay. The problem is that result goes out of scope and gets cleaned up at the end of the longest function, and we're trying to reference it later. Also, it's not here. Okay. So the problem with this. Wait, I don't really know what it wants me to do. Does it want me to remove the scope? I'm confused here, because I don't know. Do I need to remove the scope? Because that's one way of doing it, but surely you want this to be valid. Or do you define this up here? You know, I want to see if this solution is correct. Rustlings solutions. Rustling solutions, so exercises, lifetimes. This is lifetime 2. So they did this, they didn't change this. Oh, is it? Oh, okay. I mean, that's definitely something. I mean, we could just do the print there. That works too. Okay, that seems like a little bit of a strange exercise, to be honest, but lifetimes are also needed when structs hold references. Yeah. Okay. So, for example, here we have 2 strings. We're lending them to book, and then this here and this here. Borrowed value does not live long enough. This usage requires that name is borrowed for static. Okay, well, so weird. Doesn't live long enough, but I think it does, doesn't it? I mean, you need a lifetime parameter here and here. That's really strange. What does the book say about this? Lifetime annotation. So far, structs with the final. They all own the data. For example, they don't own the data here. It's pretty interesting. I'm not sure what this is. Oh, this is okay. There's a lot more of this. There's a lot more, but mostly I want this. Oh, I need to give it to the struct. Is it after the word? It is after the word. So I define a generic lifetime parameter there, and I say that it lives for this amount of time, and as long as it's referenced there, it's good. Okay. Tests1.rs. I've actually got to go and be right back for a second. So I'm just going to turn camera off just in case. and mute everything. See you guys in just 1 second, okay? Hello, hello. Sorry about that, guys. Just had to quickly pop out. Is anyone watching? No, no one's watching. But to be fair, I was just AFK for a long time. Cool things. Let's continue. We have a test. Tests are important. It says to ensure that your code does what you think it does. Oh, this is actually test, not a test. This test has a problem. It's not set anything. That would be it, wouldn't it? Yeah. Let's go here, let's go here, let's go here. Let's set equals is true when even is even. Full not is even 3. And then test 4. Okay, so rectangle, and we implement the rectangle, only change the test function, not this. Okay, correct width rect dot width rect dot height. What do you mean unexpected token input? Oh, needs to be a comma. Negative width. This test should test as. Oh, how do I do that? Maybe there is something about it here. Is there a panic? Should panic? Let's go. Was there a should panic? Don't know. Checking for panic switch should underscore panic. Ah, there it is. What's that, guys? Just closing the door. Alright, that should panic. This test should check the panics when, yeah, so go here. Okay, and then the iterators. 1, 2, 3, 4, 5. Let's open them all. Oh my god, my dog is just going crazy. Alright, when performing operations and elements within a collection, iterators are essential. Yeah, okay. So wait. This is gonna be my favorite fruits.iter. This is gonna be some. I don't know why the reference, to be honest. Custard apple. This avocado, peach, raspberry, and then this is none. Like so. Yeah, there we go. In this exercise, you'll learn some of the unique advantages that iterators offer. Okay. Step 1, complete the capitalized first function. So we take a borrowed string, we return an owned string. We might try to see that next. Okay. Oh yes. First is a character, right? There we go. First dot to upper case. Step 2, I'll put my glasses on. Step 2, apply the capitalized function to a slice of string slices. Okay. So we're gonna do vector of words dots. I love not getting autocomplete. It's just great. It's working there. Let x equals words dot iterator dot map capitalize first. That work? This that might work. No. I mean, it's own vector of string, so I mean, we could always just say. Okay, so we go. Let's word vec. Oh, actually, I could go back here and do exactly what the Rust compiler is telling me to do, which is wrap this in one of these. So we get the input, and that is a borrowed value, and then that applies capitalized first to dereference the input. I know, but this is kind of weird because I would need to validate that on capitalized first as well. Anyways, let capitalized words equals vec, like so. It's going to be actually it does. I don't need to specify because it will be done later on for me. So form word in words dot iterator capitalized words dot push capitalize underscore first, and word is borrowed, right? No, it's borrowed value. How do I make it not that then? I guess because I need to do a string from word. I'm actually pretty confused how that's meant to work. I'm being pretty thick there actually, I think, but what's this? First dot to uppercase dot collect that plus c dot as string. Yeah, okay. Also, this is to uppercase dot collect. That actually threw in collected as string, so we collect that and we do plus dot c and as string. There, we don't change anything there. Oh, we do words to owned. Okay, I understand that now. So it's a little bit more complicated. It's going to be words. So we're going to own it. We're going to make a copy. And then we're going to get the iterator. Iterator or iterator? Iterator. Dot map. We're going to capitalize first. And that's it. I think. If I do let x equals this, what do you give me? How about into iterate? Does that change? No, same thing. So, step 3, apply the capitalize first function to a slice of string slices. apply the and then return. Okay, so we're gonna go let string slice string capitalize strings equals capitalize words vector words. Oh, we could do this one line. Do this. Okay, so if we do this, dot. What do we do? Can we do as string? Can we do iterator? Dot collect? No. So I mean, this returns a vector. We do iterator dot as. No. Dot collect. And then we could collect them as strings. Oh, what do you give? Oh wow, yeah, that works. That's pretty cool. What's complaining about? To own.iterator map. Why, did this do anything differently? Oh, it needs to dot collect at the end. That's no, that looks strange. That can't be right, can it? Not x equals this. Maps into capitalize first, and then it does dot collect, which to me isn't available. That's pretty weird, isn't it? So they're giving me something that's just not valid. To owned into iterator. Capitalize first, yeah, and then they collect, and to me this is not available. Actually, oh wait, now it is. Okay. What about this? If I remove that. Value of type string. I don't know what the difference is between iterator and into iterator. Iterator yields all the values from start to finish. Okay. Over the slice. Into iterator. Create a consuming iterator that is one that moves each value out of the vector from start to end. The vector cannot be used after calling this. Oh, right. So one actually owns the vector and the data. The other one doesn't. So into iterator.collect. Nice. Get it. I got it. And if I... Oh yeah, we have to collect the strings, not as chars. Okay, I get it now. I understand. See next. Okay. This is a bigger exercise than most of the others. You can do it. How many lines? Okay. Here's your mission. Complete the divide function to get the first 4 tests to pass. Number 2, get the remaining tests to pass by completing the result with list and list of results function. Calculate A divided by B if A is evenly divisible by B, otherwise return a suitable error. So I mean, we could say if A divided by B is evenly divisible by B, I'm assuming A is bigger than B. A mod B is equal to 0, no remainder. And if it isn't equal to 0, then we return error division error of type What does it want? Not divisible. Not divisible, and it takes in dividend and divisor. Otherwise, it returns sum. No, it returns OK A over B. Okay. Unnecessary parentheses. Okay. And then mismatched types here. Not divisible. Takes in a not divisible error. A not divisible error. Dividend is A, divisor is B. Okay. Expects extra parentheses there. Expected this, found result. What are you talking about? Yeah, so not divisible error. Yeah, this one. Rust book. Enums. Enums with structs inside of them. Okay, real quick. I just want to know. What? Yeah, that's exactly what I had, no? Add that. Do they not have that? They have exactly that. Oh, I guess maybe if b is equal to 0. Yeah, we do error of division, error, divide by 0. What the? Why would I need to do any of this? It's error, right? Yeah, it's error. I'm just confused by why this syntax is seemingly okay, but mine isn't. It's the same thing, yeah. Okay, no need for those, sure. We might have meant to return this value. I mean, that's not going to fix the problem. But wait, why do I have to do this? Why do I have to do? Do I actually have to do this stuff? Just return? Well, that's not right. That can't be right. None of that can be right. What? Oh, it's because it's an if block, isn't it? If, else, escapes. Oh, and then the if itself was right. Yeah, I kind of get that now, actually. Okay. Okay, complete the function and return a value of the correct type so that tests pass. Division results returns a vector of numbers, no? Oh no, a vector of results of I32 or division error. Desired result there. So it returns result with list. What are you? So this is numbers. We turn it into an iterator, we map it into n. And we do divide, which returns a list of results. I'll do division results there. Division results here, and then the only difference here is none. I mean, so this one's a result with a vector of these. Yeah, a result with a vector of these here, or division errors, whereas this is the opposite. A vector of result of I32 or division errors, like so. This just doesn't make much sense though. Like I have to change code, right? Complete the function and return. Complete the function and return. Yeah, okay. So we're gonna do an OK of this. Divide. 27. We're gonna do an unwrap, and we're gonna return OK. That can't be right. I mean, I understand what it's asking me now, but so basically, I want to then to do what? You can be so many things here, though. I think the bottom one is correct. I don't understand this one though. So, oh, it wants to filter. Right. So it's way simpler than I thought. I thought there was something clever to be done here. But this one is actually just going to be also the type. The type's correct. Okay, so the type is going to be division result dot filter on n and n dot is okay, and we collect. That's weird though. That's really strange. So we filter on those that are okay, and then we're gonna collect all those that are okay, and that somehow wraps it in that. Why don't I have to put an okay around there? Okay. What does it say here? Expected vector result. Yep. And you are dot collect at the end. And actually I can just do this. Alright. Let's continue. Iterates for complete this function to return factor of a number. Try not to use imperative style loops, additional variables. For an extra challenge, don't use recursion. Ooh. So I mean, this being an iterators thing. Okay, try not to use. Okay. So to do this, we need to go and create an iterator from these numbers. And then we need to, go like, I don't know, if we want the third, so factorial digits, what we can do is we can like make an iterator with just, if we want the fifth one, for example, with 1, 1, 1, 1, yeah, we can do kind of a rolling collecting. So we can go, we can say, right, so I want the 0th plus 1, 1, 2, and then 2 plus it's the previous 2, so Oh, that's weird. So I mean, recursion is really, really easy here. But you want to start with the first two. I don't know how you don't do an if statement at the beginning. I'd love to know. So let's read. Oh, list. It's a fold. It's Haskell. I get it now. I think so we do a list from 1 to num. They took away. They did +1 here because they don't. You're going to be 1 off. Oh, +1. Oh no, you can just do equal there. Dot fold. It's a fold. Fold every reference into an accumulator. Yeah. The initializer is going to be 1. And then we're going to go... The function here is going to take in a value, x, and it's going to do x, comma, accumulator. What's this do? And we're going to fold, take the leave, yeah, we take the previous two. So like previous -1 plus previous -2, but how do you do that? Accumulator times x. And accumulator comes first. Accumulator times x. Oh, there is no. But why does this work? So we start with a list of 1, 2, 3, 4, 5. Now we're going to start 1, and it's going to go 1 plus 2. No, 1 plus 1 is 2. And then it's going to go, okay, 2 is accumulator, and the current number is 2. It's going to go 2 plus the previous. Plus 1. Actually, I have no idea how this works. If we're at 3, the accumulator says 3, but we are at 3. Oh, wait, I forgot the times. Okay. So if we're at 1, this is the accumulator. 1 times 1 is 2, and then it's going to go the accumulator, which is 2 plus 2 lots of the accumulator, which is 2, which is 6. What? That's not right. 1 dot equals num. Unless this does something else. I don't understand. I don't get it. I actually don't get it. Fibonacci folding solution. Why am I stuck? Let the type schedule. I mean, yeah, okay, cool. Was there a video maybe? Fibonacci folding. No, Fibonacci folding solution. Explained? Diagram? Not this. I'm just confused. It's weird. Because what if I do print line of 1 dot dots equals num? Yeah, like so. Like this then. Okay. What if I go for 1 dot dot equals num for I in this print line I. What is the print line? Doesn't tell me. Okay. Now I need to know. I need to know. I think the tests test v rust main.rs func f and main takes in this for I in 0 that equals 5. No, it's going to go between 0 and 5. Yeah, of course. But how that gives you a Fibonacci solution is actually kind of weird. It's like 1 starts with a 1. Let's go. Oh, it's just times, it's not adding. Oh yeah, it's just times, it's not adding. So 1 times 1 equals 1. It's going to go to 1 times 2 equals 2. 2 times 3 equals 6. Oh no. No, hold on. 1 plus 1 times 1 is 1. And then it goes the accumulator. 1 plus 2 times the current value, which gives 3. Then 3 plus the current value of the accumulator times 3. Bro, what what is going on right now? I'm so confused by this. Anyways, otherwise, that's weird. I don't get it. Okay. Let's define a simple model to track Rustling exercise progress. Progress will be modified using a hash map. Yeah, not sure I'm up for this, guys. This is very, very large. Yeah, might take a break here. Anyways, thank you all for tuning in. Whoever is there, if there is anyone. Is there anyone? No, so it's okay. All right, where the cat is at. Sorry to disappoint. They're gone. Not using them right now. Anyways, guys,